Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we saw the interpretation for the beta 1 coefficient when we have what we called the level model, meaning that both our x and y were in their original measurement units, be that kilograms, centimeters, liters, thousands of dollars, pounds per hour, and so on. Let's see that a little bit more intuitively by diving into this example in here. Let's say that we are trying to draw the line 2x plus 2. So um, I've dotted already here 3 points that are part of this line. And usually whenever you were asked in any math courses to draw a line, what you would do is draw 2 points, connect them, and that was your line. Now, in this particular one, point A that I have right here would have been what I would have gotten as an information when x would have been 0, and that means my y would be 2. And we also called this our y-intercept. Now, we already know that in terms of OLS estimations, the y-intercept is given in the table either by that const or basically is our beta null. And the intuition now is very clear. That is literally when x is 0, what our average y is. Now, a second point that you could have calculated is if x is equal to 1 in here, then your y would have been equal to 4, and you would have gotten point B. Okay? Then you could have gotten point C, which is when x is equal to 2, your y would have been equal to 6. These are all part of the same line. So for now, let's just assume this is literally the line that we are trying to compute. And sorry, the C should have been right here on top of the 2. So these are all the 3 lines. These are all on the what we'll assume like this is my best fitted line. And you'll imagine like I had other observations all around in here. Okay. Now, if let's say you were not given information on the line that you were trying to estimate by yourself, but let's say you were given these points and asked, well, can you find the line based on these points? What you would have done in your course is, well, I know that my slope is actually equal to my change in y over change in x. So if I had 2 points, let's say points A and B, that would have been y of B minus y of A divided by x of B minus x of A. And very easily, by taking all of these points, all of these numbers that you now have, you would have easily found that the slope is equal to 2. Now, look very carefully in here. When I compute the slope for going from B to A or A to B, so I'm just doing this one in here, my delta x is actually just equal to 1. Okay? Now, what if I do and compute the same thing, so the same delta y over delta x, but now I'm moving from point B to point C. I would have had yc minus yb divided by xc minus xb, which would have been 6 minus 4 divided by 2 minus 1, and that would have given us all over again a 2. Okay? So look very carefully. Every time my delta x is exactly equal to 1, the slope is always this 2. So the beta that I had in front of my x. And from here, we can also very quickly see that, well, actually, if I were to compute my slope, let's look carefully, delta y over delta x, but let's say we now go from A to C. So yc minus ya over xc minus xa. Let's see what we get in here. Yc minus ya is just 6 minus 2 divided by 2 minus 0, which gives 4 over 2 exactly to 2. No surprise, it's what we already knew the slope is 2. So it doesn't matter if your x here is changing from 0 to 1, so delta x being 1, also here delta x being 1, or if you're changing from 0 to 2, in your case your delta x here is 2, then your change in the y, when you move delta x equal to 2, is just going to be twice as big. So it goes from 2 to 6, okay? When you moved only 1, that change in y was identical, just the 2 units in here, okay? But that needs to be that proportional because we knew the slope in here was 2. Why am I concentrating so much in explaining to you guys like math that you have already seen in high school or even way before that? It's because we have to see in OLS regressions or like in all of these interpretations that we're doing is the slope, we're going to see it as a constant marginal effect. And we say marginal effect because remember, we're saying 1 unit change in x, okay? And as we saw just by this like clear math, it is constant. We're always getting a 2 everywhere, okay? Which means that it doesn't matter if you're increasing your x from 1 to 2, from 10 to 11, or 20 to 21, this is going to have the same impact on y, all right? And keep in mind, this is the defining feature of linearity, okay? Now, what are some of the common misconceptions that need to be corrected when you're doing this interpretation in the level model? No, misconception. For level model. Sometimes students will say beta 1 is the percentage change. And that is wrong. Remember, we're working on a level model, and we have the original units. Unless the original units of that particular variable that you have is a percentage, let's say that you have inflation in terms of a percentage, and your Excel spreadsheet, in here, it's got inflation, and you have like 2.3. So that is in percentage. Unless that is the actual unit, that is going to show only when you say that my inflation is increasing by 1%, okay? Because that is the original measurement unit, but that is not gonna travel with your y units, okay? So you can't say that your y variable is going to change by percentages. So in a level model, the beta 1 measures changes in units, not percentages. Percentages you will only have to use when the log appears. So once again, in level model, beta 1 tells you how many units y changes when x increases by 1 unit. And that's why that makes it even more imperative for you to always familiarize yourself with your dataset to understand what the measurement units of your variables are. I hope this video helps, and I will see you all in the next video, so stay tuned.